Okay, let's see what we got today. Code. Okay, mirror distance of an integer. So this is similar to what we did yesterday, but let's read the whole thing out. Define its mirror distance at absolute. So you're given an integer n and define its n is the integer. So we have to is so let's optimize. Okay, x color. So what is asking us is we're given just one int, and what's the length of int? Int is greater than 1. So let's say if you're given 10, right? So absolute of 10 minus reverse of this is what? 10 comes 0 1 minus 1. Answer should be 9. But if n is less than 10, that is if it's a single digit, you just do return 0. So seems pretty straightforward. Let's create a reverse function. So private and reverse function that takes integer n, right? Integer n, what it does is, so how will we reverse? So we reverse the number. Let's say we have 35, we reverse it by, so reverse number should be equals to 35 modulus 10. So that's 5 plus 35 divided by 10, which is equals to 53. But I don't want it to be as an integer, I want it to be, okay, so I should do something called, so if I do, so it should be, I wanted 53, not so 5 star 10, 50 plus 3, 53. So it should be while n is greater than 0, teacher reverse equals to n modulus 10, right? Whatever the remainder is, you multiply it by 10 plus n divided by 10, and z, and the new n is n equals to n divided by 10. Right, this is how we should reverse. So initialize teacher reverse equals to 0, right? And then reverse equals to n modulus 10. So let's say if I have, let me put it here. Let's say, what if the number was 129? So first our reverse, 129 is greater than 0, that's correct. So our reverse becomes 129 modulus, and it's 90 plus n modulus n divided by 10, that would be 12. That'll be 1 or 2. So this is not the right thing. I'm not doing it correct. Okay. So while n is, okay, 1 second. Let's think about it. If I have a 3-digit number, 129, the reverse should be 921. So how do we get that? So 129 modulus 10 is 129 modulus 10 is 9. And then our 129 becomes 12. Then we have modulus 2. Then we have 1. Right, so it should be 9 star 100, not 10 to the power of 2. So how do we get the number of digits? Bro. Given an integer, how do I reverse it? I could do while n is greater than 0, reverse equals to star what? Let's start 10. I did something similar yesterday. Start 10 and let's think about it. Okay, how else can I do this? 1 second. So it should be something like so if our num is greater than 0, so if our num is greater than 0, when we get, so our what, let's try to think again. 129, if I do reverse equals to 129 modulus 10, that is 9, right, plus 12, that would be for first I would need our rev to be equals to 9, and I want it to multiply by 100. So the way I want it is 900 plus 20 plus 1, and it becomes 921. That's what we want. So if I just get the 9 and multiply rev by 10, and then when it goes to second loop, it's 90 gets multiplied by 10 again. So it should be something like okay, let me minimize this. So we have something called integer rev is equal to 0. So rev should be equals to, first we want to do num modulus 10. So this way we will get our last digit, right? Then we also want to multiply rev value, initialize starting 0, so it doesn't matter, by 10. So first loop when we get 9, The second loop is 90, right? And then let me put this in this. So, and our num changes to num equals to, oh sorry, it's not num, it's n, and n equals to, and we will divide equals to, we'll keep dividing it by 10, and then this should be correct. So let's rethink again. Let me, where is that? Oh, I closed it. Skelly draw. So again, for the same 129, we want it turn it to 921. So 129 is greater than 0. Our reverse becomes 0, right? Because 0 times 10 is 0 plus n modulus 10, that would be 9. And n becomes 12. So then we have rev equals to 9, right? Plus n modulus 10, that would be 9, and num becomes, so then we have rev equals to 90 plus n modulus 10, right? That would be 92, and n becomes 1, and then rev becomes 920. Yeah, that's correct. So our reverse function is correct. Now you are given an integer n. If I return where reverse n is formed by reversing the digits of n, return an integer denoting the mirror distance of x. Absolute is denote the absolute value of x. I feel like we should use binary. You could also, so the pattern I'm noticing here is, see here, 52, 25 becomes 52, and when we minus 2 minus 5, 1, no. So, well, if I don't know if this is the optimal way, or is there maybe some kind of a bit trick. I don't know if this is a bits question. You can play with bits somehow. So when we reverse in a bit format, well, okay, what do we want to define its mirror distance as? So what do you want to return? Math dot absolute of what? N minus reverse of n. Oh, I didn't put the return statement here. Yep. Return the reverse. It should work correctly, but is this the, so what is our time space complexity here? Is O of 1, no? I think, is this the optimal path or no? So let's see how people have done it. I guess this is easy. That's why it's an easy problem. But let's just ask ChatGPT if there was another way of solving this. Okay, this is this. This is how I solved. Cool. binary. Time space is O of 1. My next main question is there another way to solve this? Maybe using bits. No, not really useful here. So bit manipulation works when you care about binary operations like AND or is about decimals based on reversing. Bits for the reverse, binary, not decimal. Completely different. Yeah, or we could do a string builder. Okay, today was pretty quick. Okay, I'll see you guys tomorrow.